Now, welcome back. Now, if 1 plus alpha, if we agree that 1 plus alpha squared is equal to 0, which is very key to solving our problem. If you express this in J notation, that means you remember that alpha squared EA, right? That is cos of 240 and sine of 240. When you express this in J notation, you have this one to be what? Minus 0.5 minus 0.5 minus J 0.866 EA. And if you express also this in J notation, EA, which is cos of 120 plus sine of 120, you have to have minus 0.5 plus J 0.866 EA. So if you now add this together, that is, you have one, if you add this together, you have what? Alpha plus alpha squared EA is equal to, when you add this together, what will you have? You will have, with the EA, when you add this together, you have minus 1. This one cancels out. So that means you have minus EA. Then EA also cancels out. Then you have alpha plus alpha squared, alpha plus alpha squared minus 1. So if you bring this back to here, you have 1 plus alpha squared is equal to 0. Also, that also proves what we concluded there. Then, now, likewise, if you have to multiply alpha with alpha squared, for example, because 1 plus alpha squared gives you 0. What about alpha multiplied by alpha squared? Right. Of course, which is alpha cubed. What does alpha? So this means you have this one minus 0.5 plus J 0.866 into minus 0.5 minus J 0.866. If you multiply this out, what are you coming to? You come to 1, which means alpha times alpha squared, is equal to 1. That means alpha cube is equal to 1. Right. So on that basis, let us move on. Let's look at what our positive phase sequence and the negative phase sequence and zero phase. So for all the phasor diagrams that we have here, we have them made up of